Alright, so what I'm going to do is I'll do a little video to review for you guys for solutions testing. I know it's going to need some of you guys fit. They're asking you total number of grams of solution. So what's your unit of measurement, or what's your unit solution? So you want to pay attention. See how they're giving you molarity there? Remember, the definition of molarity is moles of solute over liters of solution. So when I go to set it up, that's your equation. All you really need to do to solve for the number of grams, a quick solve method, although on the honors chem exam they're going to want you to do it in two pieces, just remember this. Molarity times liters always gives you moles, because that's what you're doing right here, because I have liters and molarity is going to help me find moles, times molar mass is a quick solve. You just have to multiply three numbers together. That's all you have to do to be able to do it. But if it's a free response problem, they want you to show your work. So what I'm going to do is I'm going to insert the numbers in here. Well, I have 0.5 liters, so I'm going to go 0.5 here on the bottom is my liters, equals 1.0 m, and then I find my x. So when I multiply that out, I'm going to basically get 0.5. Then all I have to do is multiply times the molar mass of HI, which H is 1 and I is 127, so 128. So all I would have to do here is kind of like what I just did. Drop it into a grid, so I would drop it into a little grid, get the number of moles. What I said was going to be 0.5. 1 mole is equal to times 128 grams. So I would do that. Realistically, all I'm doing is taking the molarity, which is 0.5, the liters, I'm sorry, actually the molarity, which is 1, the molarity, which is 1, the liters, which is going to be 0.5 liters, and the molar mass, which is 128. You always get grams of anything in a solution. Grams as far as anything in molarity anyway. So 1 times 0.5, that's a horrible looking parentheses. That's 0.5 times 128 will give you your answer. Correct answer they have on here is B. So that'll give you B. It's basically half, so half of 128 is 64. That makes sense. Next one, we go to the next one. It says in a solution of sugar and water, sugar is a solute, water is a solvent. You need to know the definitions. Solvent is basically whatever does the dissolving. So the solvent is always going to be responsible for what does the dissolving. The sugar is the solute. So let's say you go to make grape Kool-Aid, right? You need a little purple sugar. So you take a little purple sugar, and then you basically drop that into a pitcher, add water. The sugar will dissolve in the water. So the sugar is the solute, and the solvent does the dissolving is going to be water. Next one, substance dissolved in the solution is the solute. That's just a definition or vocab. Number 5, stirring a solute or solution mixture makes the solute dissolve faster. That's a way you can speed up dissolving. Increase the solubility. Solubility is determined by the nature of the substance necessarily. And temperature, that's the only other thing that would really affect it too much. And then it doesn't increase the solvent's capacity to dissolve, it just makes it dissolve faster. 7, what is the term for a substance that provides ions when dissolved in water? Ions are provided by electrolytes. I know they talked to you about I. How do you find I? Well, the first thing you do is if they give you a compound, like for example, NaCl, the first thing you do is check. If the first element is a metal, it breaks into ions, and then you're just counting the ions. So Na is 1 ion, Cl is the second ion, the I factor would be 2. If you take something like C6, H12O6, if I check the first element is a nonmetal. That means the I factor has to be 1. That's the way it works. So if it doesn't have a metal as the first element, then that value is going to be 1. If it has a metal for the first element, so like if I took something like this, Na2SO4. Sodium, if I look on the periodic table, is a metal, right? So sodium is a metal, so then what do I have to do? I figure out the number of ions. Well, my subscript tells me I have 2 sodiums. Remember, sulfate is a polyatomic ion, so every polyatomic ion, each one counts as 1 unless it has a parentheses. So in this case, I would have an I value of 3 ions. So that's how you basically do that. So when we talk about electrolytes are ionic compounds. They dissolve in solution. How many grams of ammonium chloride are contained? So here they're asking you how many grams again. And notice how I have molarity. The quick solve method is going to be M times L times MM. I just have to multiply those 3 numbers. I'm going to get the answer. All I'm going to do is take my molarity, which is 2, times my liters, which is 0.5, times my molar mass, which is 53.5. I will get the answer very, very easily that way. So if I look, so you end up getting 53.5 when you're all said and done. If you have to do it 2 steps, if it's a free response, you just do moles over liters is equal to M. So I would take my M, which is 2.0. It's the same thing. 0.5 on the bottom is here. Multiply those. Cross multiply, you solve for moles. Then you pop it in a little grid with molar mass, and the molar mass happens to be 53.5 is equal to 1 mole, and that's how you quick solve it. Now, next one. What is the molarity? The definition of molarity is moles of solute over liters of solution. So I'm going to check. Do I have liters? I do, so I'm going to go 0.50 liters goes right there. I need moles. That is not in moles. So my first step is to convert it. I'm going to go 20 grams of CaBr2. I'm going to divide by the molar mass of that sucker. The molar mass of that is going to be... So what you do is you take the 20 grams of CaBr2, divide by the molar mass, which is 199.9. I'm going to get 0.10. That's a horrible 0. And then I'm basically going to double stack. I'm going to go 0.1 divided by 0.5. And ultimately that's going to be, what does it come out to be? 0.2. You're going to end up with 0.2 molarity. Remember, molarity is moles over liters. So I check, I got liters, I drop it on the bottom. I just need to add moles on the top. I check I have grams, I convert it, double stack it, and I'm good to go. Bam. 11, compared to pure water, the solution of calcium chloride has what? Well, the way it works is if you have the number of particles, or as your I number is greater, think of it like this. Easy way to remember it is the boiling point is higher, the freezing point is lower, and the vapor pressure is lower. So when you go to do this, so they're only asking about boiling point, freezing point here. Just remember boiling goes up, freezing goes down as the number of particles increases. So like here, calcium chloride has 3 particles to it. It's CaCl2, so that's going to break into 3 ions, right? Well, water, pure water has 0. It has an I value of 0. It always does. There's no particles in there. Well, what did I just do? So ultimately what you do, whatever, is you check. So calcium chloride has what when you look at it? Calcium chloride has 3 ions, so its I is higher, which means it's going to have a higher boiling point and a lower freezing point. So B is going to be your answer for that one. Calcium chloride, more ions or more particles, automatically just know, I guess, higher boiling point, lower freezing point. If you flip it the other way around, it flips around. Next one, if we look right here, hold on one sec. Next one, what is the molality of KBr? Well, molality is moles of solute over, this is a little different than molarity, kilograms of solvent. So when I go to do this, I got to pay attention. I look at the 2 numbers. The bigger number, most of the time, or pretty much every time, even in AP, is going to be the larger. The larger value is going to be your solvent. It's always in there to a greater extent. So I'm going to automatically take the bigger number and change it to kilograms by just moving the decimal over 3 places. So I go 0.697 kilograms of solution. I need moles on the top. Problem is I have 221 grams, or 2.21 grams of KBr. So the first thing I got to do is divide by the molar mass of KBr. So anyway, what we do is we take 221 divided by, I'm going to round this off, 119 roughly, and I get 0.0, we got here 186. That is going to be my moles. So I double stack it to get molality is going to be moles of solute over kilograms. So I'm going to just do 0.0186. I move the 0.697 over here. So I'm going to go 0.0186 divided by 0.697. Bam! I get 0.0267. Bingo. B for bingo right there. Bam. Next one. 15. Calculate the mole fraction. Remember when you do mole fraction, the first step is change everything to moles. So you basically, everybody's got to be in moles. You're totaling the moles. So the first thing I do is prepared by 16 grams of urea. So I'm going to do this. 16 grams. They give me the molar mass of urea is 60. So the first thing I'm going to do is this. I'm going to just go 16 divided by 60 I get what is that? How many sig figs? 2. So I'm going to get 2.27 moles of urea. The next thing I'm going to do, take 39 grams of water. So I take 39 grams of water. Molar mass of water is 18 grams is the molar mass. So then I take 39. So I'm going to go 39 divided by 18. Boom shakalaka. I get 2 sig figs 2? So 2.2 moles of water. Now we're in business. Whenever you do mole fraction, you change everything to moles. And then what I'm going to do is I'm going to go here, and I'm going to total them on the bottom. So ultimately what I'm going to do is I take 2.2 plus 0.27 is my total moles on the bottom. And what do they want the mole fraction of? Of urea, so the smaller number. So 0.27 goes on top. So then I total this out. Let me see here. I'm going to go 2.2 plus 0.27. That's going to give me 2.5 on the bottom when I'm all said and done with that. And then I'm going to take 0.27 divided by 2.5, and I get a mole fraction of basically 0.11 would be my mole fraction of urea. And if I look there, D is the correct answer for that. So whenever you go to do mole fraction, remember, I need everybody in moles. So the first thing I do is I divide by molar mass, switch everybody to moles, put the total on the bottom, the part you want on the top, and you're good to go. Number 1, you need to make a solution. You need to make a 0.8 solution. How many milliliters can you make? Well, dilution is this. M1V1 is equal to M2V2. Typically, this is always going to be your stock. This is going to be dilute when you're all said and done. The key to remember is of A, the magic phrase, that links 2 together. So those 2 are always going to be linked together. Mathematically, you're always going to cross multiply, so it's going to be equal either way. So when I go to set it up, but I'm making a dilution. This is a smaller amount, so I'm going to put my molarity for that here. I'm going to put 0.800. Molarity goes there. I'm solving for V2 equals. Then I come over this side. My concentrated solution was 1.5 molar and 53.4 milliliters. Check my units, because remember I got to cancel down to 1 unit. And then what I have to do is I'm just going to cross multiply. So it doesn't really matter what side you set it up on, because mathematically when you go to do the solution, you're going to be okay either way. So I'm going to go 1.50 times 53.4 divided by 0.800. Bam. I end up getting 100 decimal, if it's 3 sig figs, 100 milliliters. So I'm going to be able to make 100 milliliters of that stuff based on that dilution. So anytime you use a dilution, it's M1V1 is equal to M2V2, and it depends on what you're solving for. 2, what is molarity? Well, molarity is moles over liters. I check. That's grams, so that's not in moles, and that's milliliters. That's an easy fix. So I just changed it to 0.500 liters on the bottom. That's not in moles yet, so I have to divide by the molar mass of CaCl2. So when I calculate the molar mass of that, I get 111 grams is in the molar mass. So I take 42.5 divided by 111. I'm going to get 3.83. So then that's my moles. I go 3.83 on the top. So I'm going to go 0.383 divided by 0.500. Bam. When I go, I get 0.766, capital M for molarity. Next one, a stock solution is available. How many milliliters are needed? So when they ask you how to make a solution, they're really asking you what V1 is. That's what they're asking you, how to make. So the first part of how to make a solution is you're going to solve for V1. But remember, of A is the magic words. Of A, it doesn't say of, it just says of there. Those 2 are linked together, and that one is a stock solution. So all I do is do this. I go 1.0 moles here, goes there. I'm solving for V1, and then I'm going to just take 0.75 M is equal to 100 milliliters on this side, and then I get molarity is going to cancel. Do a little cross multiplication. Okay. So when I go and solve it, when I solve for V1, I'm going to need 75 milliliters of stock. Something they may ask you to be aware of is they may ask you, well, how much water do you need? If this is my stock, all you have to do to find water is you just go V2 minus V1 when you're done. V2 or volume 2 was 100, so I would just go 100 minus 75 milliliters, and that's, if they do ask you this, you would add 25 milliliters of water to it. So that's like a typical problem they could add on to that, just so you know. 5, how many grams of Na2SO4 must be added to 950 grams of water to make a solution with 2.95 molality? Well, that's a gangster little m molality. So when I go to solve for it, molality is moles over kilograms is equal to little m. It's the same type of problem I was talking about before. The first step is you solve for x, moles here. Then you're going to transfer moles and do a quick little conversion. Technically, now if this is a free response problem, you got to show all your work. But if this is a multiple choice problem, watch this. What I'm going to do is I'm going to take the little gangster m, molality, times kilograms times molar mass. So the only real difference from the other formula I showed you is kilograms instead of liters. But if you go little m kilograms times molar mass, you will get the grams to make a solution. It's the same thing you're doing here because you're going kilograms times m, and then you just put molar mass in the grid if you think about it, right? So you're just multiplying those three numbers. So the molality is 2.95. Kilograms is equal to 0.950 because they gave it to me in grams. So if I was going to get moles here, I would just do this. Think about this. I would just go 0.950 times 2.95. I get 2.80. So if I did solve it using this, I would just get 2.80 and move it over, and then multiply times the molar mass. It's the same thing. Molar mass of Na2SO4 has got to be right around 142, ballpark. I just ballpark that, so be a little bit more accurate when you do that. Times 142, I get 397. How many figures in this? 3. So 398 grams is what your answer would be. Same principle. It's the same idea. You start with the formula, but in this case, you're just going to go kilograms times molality times molar mass anyway. If it's a multiple choice problem, quick solve it. Make sure you show your work on their tests. Otherwise, that's not so good. Percent concentration, super duper easy. When you go and do percent composition, percent by mass, it's grams of solute on the top, and it is grams of solute on the bottom, plus grams of solvent, equals solution times 100. So I'm trying to find the percent. Well, I go 25 on the top, 25 plus 225 on the bottom, times 100, plug it into your calculator, and you're good to go. I'm not going to keep doing that one. You can do that one. And that's it from the sheet. Hopefully that helps. If I get a chance later tonight, I'll put a quick little solution stoichiometry video.